predictive model for the optimization of air conditioner usage. Here is a very basic flow of what I have done for the project, starting with business understanding, data preparation, modeling, evaluation, and last but not least, deployment. So to give a background of the project that I have done, we actually understand that Singapore actually has the highest installation rate of air conditioning in all of the ASEAN countries, and out of a Singaporean's household bill, 40% is made up solely from the usage of air conditioning. And we can only imagine what businesses have to pay when it comes to using air conditioning in their much more bigger offices. And as a result of this, there's a high amount of carbon dioxide being released into the atmosphere, which worsens the case of global warming today. And hence, we believe that there should be a more efficient way to utilize the air conditioner. So hence, I created the optimal start-stop predictive model, which uses variables such as outside air temperature, outside relative humidity, to predict the time taken to cool down the room to an optimal temperature of 24 degrees Celsius, and the duration of which the room can be maintained at that temperature. This allows the users to calculate how much time they need to leave the air conditioner on, hence enabling a more efficient use of the air conditioning. This project was used specifically for the Assets and Facilities Management Office in Temasek Polytechnic in effort to conserve energy. So these are the two main things that you have to know, and this is how I decided to calculate the optimal start and optimal stop time. So for optimal start time, we will be calculating the optimal start time based on how long it takes to cool down the room to the desired temperature, which is known as the cooling time. And we will be using this formula, T minus Y equals to optimal start time, and using that formula to work backwards to get the specific optimal start time. T being what time you want it to be the desired temperature by, and Y being the predicted cooling time. Now for optimal stop time, we'll be using quite a similar concept in which we will be calculating it based on how long the desired temperature can be maintained before it heats up 1 degree Celsius once the air conditioning is switched off. Once again, you can find the exact time by working backwards based on this formula, T minus Y equals to optimal stop time. T being what time people leave the room, and Y being the predicted how long desired temperature was maintained. So during the modeling portion of the project, I have used a linear regression, and using Anaconda and the Python programming language, I have used the scikit-learn library to do the following, which is to impute the independent and dependent variables and splitting the training and testing dataset. And this is all done after cleaning the dataset using NumPy and Pandas packages. And here there is a chart showcasing how accurate the predicted values are when compared to the actual values. They have a pretty linear and strong relationship, and it also shows that here that they have a RMSE of 8.83. So that was for optimal start. Now for optimal stop, we also use linear regression as the primary model, again using the scikit library to do the following as shown on the slide here. Once again, it has a very linear and positive relationship showcasing how accurate the predicted models are in comparison to the actual values. So the RMSE for the optimal stop is 5.77. So once we have created such models, we actually went ahead and followed the same steps for another different type of model. In this case, we use elastic net regression, following the same steps, only a different type of model. And we have seen that for both optimal start and optimal stop, linear regression still has the better error rate and shows that it is more accurate in predicting the values. So once we have chosen linear regression as the primary model because it has a better and lower error rate, it's time to use the model to predict the values. So as we have mentioned on how we would like to predict the specific optimal time, this is the codes that we use on the Python file, in which for optimal start, those are the variables here, and you will just input the values of each variable. For example, the static supply air static pressure was 208 0.9 at that certain time, and so on. Just input all those values, and once you run it, you will get the minutes taken since switch on. So it means that this is a cooling time. It has taken 55 minutes since switched on, since the air conditioning was switched on, for it to reach the optimal temperature. Hence, if you know that you want to have the air conditioning switched on at 8:30 a.m. and it takes 55 minutes to cool down, working backwards, that will be 7:35 a.m. Hence, the optimal start time will be 7:35 a.m. Now, in comparison to the fixed 7:30 a.m. that the office would usually switch on the air conditioning at, there is a 5 minutes of energy conservation. And though this might not seem a lot, however, if you do it for a whole week, that is already about 35 minutes of energy conservation, and this is excluding days on where it is colder and it may take even lesser time to cool down to the desired temperature and have more energy conservation. Again, following the same concept, this is for optimal stop. We will use T minus Y equals optimal stop time as a formula. Again, just input the values of each variable, run it, and you will get how long the 24 degrees, which in this case is the desired temperature, is maintained for. So here it says it is maintained for 60 minutes since switch off. So if you know that everybody leaves at 8 p.m., hence nobody is in the room to enjoy the air conditioning anymore, 8 p.m., 60 minutes before 8 p.m. will be 7 p.m. Hence the air conditioning can be switched off at 7 p.m. instead of 8 p.m. and that is already 1 hour of energy conservation. Now, these are the key benefits of actually using this predictive model. It is energy and money saving. The energy conservation from minimizing air conditioning will lead to a direct increase in the utility bills. In addition, it would also reduce the amount of carbon dioxide being released into the atmosphere. Now, to make this predictive model possible, these are the key technologies that I have used. I used Python and Anaconda as mentioned before. And to clean the data, I used NumPy and Pandas. And since we worked with a lot of datetime type of data, I use a datetime module to assist me. And in predicting the cooling time and how long the desired temperature is maintained for, I use scikit-learn and use the two main models, which is elastic net regression and linear regression. So in the future, we hope to be able to I hope to be able to enhance this project by allowing for an automated on and off for each air conditioning, so it doesn't have to be manually switched on and off, and setting your preferred temperature set point. So currently, this model is done specifically for the EFM office in Temasek Poly, which has chosen 24 degrees Celsius as their preferred temperature set point. So hopefully in the future, with more data, we get to cater to much more venues who have different preferred set points. And our industry partner for this project is Azindian. So for more information, please contact us at the following information.